Hello guys, so in today's video we're going to be looking at spanning tree protocol, right? So spanning tree protocol is a network protocol used in Ethernet networks, in layer 2 networks to prevent or avoid loops, right? So loops occur when some kind of messages are sent on your layer 2 network. So some kind of messages can cause loops if spanning tree protocol is not enabled. Some messages like the app message when a device is trying to identify the MAC address of another device, or a DHCP discover message when a device on your network is trying to discover a DHCP server. Another one is an STP BPDU, that is spanning tree protocol bridge protocol data units. These are messages that are used to manage the spanning tree topology within your network. So they can either use it to identify root bridge, change blocked and block ports to forwarding ports and things like this. So another one is unknown unicast flooding, when a switch doesn't know the unicast address. It floods out to all its ports to identify what device has that address, right? So these are some broadcast messages that can cause a loop within your layer 2 network. And a broadcast message would typically be sent out of all ports except the receiving port. That is, if a port was sent if a switch was sending out broadcast messages, it would send it out of all its ports except the port it received that message from. Now, when that message gets to a destination, its destination, let's say it gets to another switch, the other switch that receives it will do the same. For instance, for a unicast flooding, if that switch still doesn't know the address of that device, it's going to flood it out of all its ports except the receiving port. So if this continues indefinitely, it can bring your network to a halt, it can bring your network to a stop and disrupt a lot of services, right? And this can happen if spanning tree protocol is not enabled or configured correctly within your network. So on the left, we have two different networks here where I'll use to explain a network with spanning tree protocol, which is the one on the left, and on the right, one without spanning tree protocol. Now note, these devices, the switches on this on the packet tracer that you see on my screen, have not been configured. They were just pulled out of this section of packet tracer and I've made this connection, but no configuration have been done on any of these devices. So the only configuration that has been done is on the end devices where I've configured the IP addresses. So this is 10.3, this is 10.4, this is 10.5, and that is 10.6 on a /24 network. So this topology currently has spanning tree enabled, and we're going to see what it looks like, right? So I'm going to connect these devices. I'm going to connect this one, and as you can see, the indicator lights are showing us that both ports are up and are running. So I'm going to go into one of the devices, one of the switches, switch 0, and I'm going to check out what spanning tree is enabled on it. So we're going to say show spanning tree, right? Now it's going to show us the information about spanning tree, right? So it's going to show us the ID of the root bridge, the address, MAC address of the root bridge, and it's saying that this bridge is the root, meaning that this is the root bridge for this topology. It's going to show us the priority and a couple more information. As you can see, all its ports are this one is forwarding and this is learning. This is probably the port I just connected the PC to, so it's going to take a while before it leaves the learning state. So that is it about this particular switch. If I tried to ping dot 4 from this PC, that is going to work because everything is stable, right? 192.168.10.4. As you can see, it already is pinging, and 4 sent and 4 received. That's a successful ping, right? If we go over to this switch and we check for spanning tree information on the switch, we'll see spanning tree, show spanning tree. We're going to see that this device is not the root bridge, right? both of his ports are forwarding because it's just there's no redundant connection, so both of the ports are forwarding and you will not see any blocked ports, right? So everything seems to be stable and working, and this is running the original state of spanning tree, right? Which runs spanning tree for VLAN 1 for just on the VLAN 1. So that is working perfectly. Now for the second topology, right? If we take a look closely at the switches, you see the indicator lights. One is circular, the other ones are triangles. Now this is trying to show us that there's something different about this topology. If we go into one of these devices and click on enable and then do show spanning tree, right, we're going to see something entirely different because there's a redundant connection. So spanning tree would make changes on your topology once there is a redundant connection, unlike this one where there's no redundant connection. So as you can see, we have one port in a blocking state and we have another port in a forwarding state, right? And this is obviously not the root bridge because there's a port that is being blocked, right? Root bridges don't have blocked ports. So as we take a look at this, we would see the information about the spanning tree, the bridge ID, the parity, the uptime, the hello time, the forward delay time, and all of that. We'll see that it's trying to keep this topology stable by blocking one redundant link. Now, if we go into the next one and we go to CLI and we do enable and we do show spanning tree, right? Now we're going to see that this is the root bridge, right? This bridge is the root, and we're going to see that its ports are all in the forwarding state. We're going to see every other information about the spanning tree, that is bridge ID, and every other information that is important. Now everything is going to work normally like the first topology, right? If we tried to ping, we would have ping 192.168.10. That should be 6, right? So if we ping it, we would be sure for that this ping is going to work, right? So let's just see how long that would take before the ping gets through. So just one went through. If we ping again, we would see that all of them go through successfully. So send 4, received 4. Now if for some reason we disable spanning tree here, we would see how important spanning tree is on a topology. Now note that the first ping that we tried worked, right? Now if we go ahead and say no conf t and we do no spanning tree VLAN 1 and we go to the next switch and we do the same thing, enable conf t no spanning tree VLAN 1. Now if we tried the ping again, .6, you would already see from the lights on the device that something is going on. You see how it's going crazy right here. FA0/1 and 0/2, both ports are showing as up, right? So the network is going to be unstable, and you notice that from the pinging, right? So you see request timed out on the first one. It shouldn't have timed out at all, and then you see these ones going through, and this may be followed by a series of request timed outs, right? So the network would be unstable, so it's going to flap and it's going to keep doing that. So this would show you how a topology without spanning tree protocol would work. Now let's go out of these ones and introduce two different computers that these switches know nothing about, right? So the advantage of this is that the switches are going to try to do send an app message to identify what devices these are, and before this starts pinging, right? So we're going to configure them as 10.7. I'll copy that /24, and I'll configure this as 10.8, right? /24. We'll close out from here. Now we'll connect them. Now that is .7. We'll try to ping .8 from .7, right? So if we go to command prompt and we do ping 192.168.10.8, right? Let me confirm that that is right. Yes, so that is right. So we ping and we wait. So remember when we first pinged on this network, the first four failed and the last one was successful. That was when spanning tree had just been spanning tree was still enabled. Then when it was disabled, you could see that the network was flapping. But this one, spanning tree has been disabled entirely. You would notice that the ping is not going through at all. It's not going through at all. So it's going to keep trying to reach out to that device, and it's not going to be able to do that no matter how many times it tries because of spanning tree, right? So let's see the fourth one. And it failed for the entire four. Now if we go back into the devices and enable spanning tree VLAN 1, and we go back here, you can see that it's already becoming stable, right? Spanning tree VLAN 1, this is the original version of spanning tree 802.1d, right? Yeah, that should be it. So if we close this out and just try again, it's going to take some time for the network to converge, so a couple of pings might fail, but if we give it time, we would have a successful ping. Okay, let's try one more time. Okay, second time is the charm, right? So you did work, and 4 pings were sent and 4 were received successfully. So spanning tree protocol is really important, and ensuring that it is well configured and well tuned on your network, and ensuring that your ports are secure is very important. So scenario is if you have switches that are in areas that are not well secured, let's say switches that are in areas that is not well secured, where there's not a lot of staff, trusted staff in those areas. This could be areas such as your reception area, your security house, where you don't have a lot of people there, right? You need to ensure that those switches are well configured, because if an external device is introduced to the network with a terrible spanning tree protocol configured on it, or a messed up configuration on it, and it connects to your network, it could bring the network to it connects to your network redundantly, it could bring the entire network to a halt, right? So ensure you have spanning tree well configured and tuned within your network. Thank you for watching, and please do like, share, repost, and give me a follow, and keep an eye out for more videos that will teach you how to ensure your network is resilient. Thank you.